This one is the advantage of vector quantizations over scalar quantizations. First one, in vector quantizations can lower the average distortions with the number of reconstructions level held constant. Second one, vector quantizations can reduce the number of reconstructions level when distortions is held constant. Third one, the most significant way vector quantizations can improve performance over scalar quantizations is by exploiting the statistical dependency among scalar in the block. Vector quantization is also more effective than scalar quantizations when the source output value are not correlated. In scalar quantizations, in one dimension, the quantizations region are restricted to be in intervals. Like as for output points are restricted to be rectangular grid. And the only parameter we can manipulate is the size of the interval. While in the vector quantizations, when we divide the input into vector of some length n, the quantizations region are no longer restricted to be rectangles or squares. We have to freedom to divide the range of the input in an infinite number of ways. In scalar quantizations, the granular error is affected by the size of quantizations interval only. But in the vector quantizations, the granular error is affected by both shape and size of quantizations interval. Vector quantizations provide more flexibility toward modifications than scalar quantizations. The flexibility of vector quantizations toward modification increase with increasing dimension. Vector quantizations have improved performance when there is a sample to sample dependency of input while not in scalar, and vector quantizations have improved performance when there is not the sample to sample dependency of input while not in scalar quantizations. And last, for a given rate, use of vector quantizations result in a lower distortions than when the scalar quantization is used at the same rate. So this one is the advantage of vector quantizations